I want to recreate a nostalgic animation piece from my childhood. If you remember back in the day, we used to have these things called screensavers, which would play if you left your computer idle for too long. One of my favorite screensavers was 3D pipes. What made it special was the fact that it was procedurally generated, so every time it played, it would generate something completely different. And I'm not lying when I say this was the peak of entertainment back in my day. I would sit in front of a giant CRT monitor blown away by colorful pipes running around the screen. So anyways, I'm learning WebGL with Three.js, so I thought it would be a fun challenge to recreate the original 3D pipe screensaver in the browser. So let's dive in. The first thing I had to figure out was how to represent the pipes. For this, I used a technique called random walk. There is nothing special about this technique. It pretty much does what it says in the name. You start at a random point and then randomly move in any direction while making sure you don't undo your last movement. For example, you can't move forward followed by moving backward because you would just end up at the same place. So the very first bit of code that I wrote was a function that generated a list of positions based on the random walk algorithm, and another function that draws a box at each of those positions generated by the random walk algorithm. And with that, we get a very nice visualization of a very basic random walk algorithm. This looks neat, but it has a problem. The algorithm makes sure that it doesn't immediately walk in the opposite direction, but there is nothing stopping it from looping back to an existing position. This is why some of the boxes look more opaque than the others, because it is drawing multiple boxes in the same position and their opacity is adding up. I tweaked the rendering function to draw these overlapping boxes in a different color. We can exaggerate this effect if I limit the moment of the algorithm to only 2 axes. The fix for this problem was simple. When generating new positions for a pipe, I simply keep track of the positions that have already been generated, and if I come across a same position again, I just simply ignore it and generate a new one. And with that, the generation already looks much better. Next up, I wanted to add some variation to the length of the pipes, because right now the algorithm takes a turn at every step of the way, and this is not realistic when you think of pipes. We want the pipes to go in a certain direction for a while and then take a turn in the random direction. To implement this, I simply generated a random number at each step, and if it was above a certain threshold, the pipe would take a turn, otherwise it would just continue in the direction it was previously following. And with that simple change, we have a generation that looks a lot closer to the original 3D pipes animation. The last thing I added to the algorithm was a boundary check to make sure that the pipes don't run too far off the screen. And with that last check, the pipe generation algorithm was complete. Next step was to figure out how to draw actual pipes instead of just boring boxes. So the first thing I did here was to replace the box geometry with a cylinder geometry so that the segments look closer to a pipe. Obviously at the start it looked terrible because all of the segments were rotated the same way. So I needed to figure out how to rotate each segment based on its direction, and that's pretty much exactly what I did. I wrote a helper function that accepted a direction and returned a rotation. After plugging in the rotation, the scene looked much better. Next up, I had to address the more complicated part, which is the turns. Right now the turns are broken because by definition a turn is represented by 2 directions, but it is only being represented by one cylinder geometry. After doing some trial and error, I figured out an approach that worked. I wrote a check that compared the direction of the current segment with the next segment, and if they were different, it would treat that segment as a turn. So when the algorithm detects a turn, instead of drawing one cylinder geometry, it draws 2. The rotation of the first geometry depends on the direction of the current segment, and the rotation of the second geometry depends on the direction of the next segment. And I added a sphere geometry at the center of these 2 new geometries to complete a joint. After doing all that, I was finally so happy to see a single coherent pipe without any breaks or glitches. But my work was not done yet. I still needed to draw multiple pipes. Luckily, this was an easy problem to solve, because all I had to do was to just pre-populate the set of existing positions with the positions of the pipes that have already been generated, and since the algorithm is already designed to avoid the positions that already exist, it just worked. Now all that was left to do was to make the pipes look more pretty and colorful. To do that, I updated the render function to pick a random color each time a pipe is rendered. I also switched the material of the pipes to the mesh Phong material, and it is a type of material that is reactive to the lights, and if there are no lights in the scene, this material would simply appear black. So to fix that, I added some directional lights to the scene as well. At this point, I had implemented everything that I wanted, but I wanted the project to be more interactive, so I added some UI that allows the user to tweak the parameters and generate different configurations of the pipes. This turned out to be a great addition because even I discovered some interesting configurations after messing around with the parameters. For example, if I squish the bounds to the lowest values possible, I get this neat looking cube made out of pipes. If you squish only 2 axes, then you get what looks like a tower made of the pipes. And lastly, if you squish only 1 axis, you get a wall of pipes. I was having too much fun and I probably would have wrapped this project up here, but then I had this brilliant idea of a new feature. What if you could share your creations with other people? And by that, what I mean is that, let's say you had an interesting generation of pipes and you wanted to show it to someone. How would you do it? Right now, you can't because it is completely random, so anyone coming to the website would just see something different each time. At first, this felt like a difficult problem to solve because I was thinking of deserializing and serializing the positions of pipes and somehow encoding them in URL and sharing the URL and a bunch of other bizarre solutions that I had a feeling were never going to work. So after fumbling around for a while, I had this realization that made me feel both smart and stupid at the same time. I could just use a seeded random number generation because all the algorithm is doing is generating random values. And if I can make these random values deterministically random, say using a seed, then I can just put the seed in the URL and use that to generate the random values. So as long as the seed is the same, you get the same output and you can just easily share a small URL to share your creation. Lucky for me, Three.js has a seeded random method under its math utilities, so all I had to do was replace my math random calls with the seeded random method calls. Sounds easy, right? It should not take more than 5 minutes. Well, I managed to spend 3 hours on this because I forgot to remove some hard-coded variables and kept wondering why my seeded RNG wasn't working like a seeded RNG. Yeah, not proud of that. So after that, it was possible to share your creations with anyone. All you had to do was share the URL with a seed in it, and anyone you share it with will see the same thing that you saw. At this point, I had added every feature to this project, and so before I get any more bright ideas for new features, I decided this is the point where I would call this finished because I was pretty happy with it. And don't get me wrong, there is still a lot more I could do with this project. For example, performance is something I wanted to look into, but I'm still learning more about it, so I did not go much into it. All in all, I'm very happy with how this project turned out. I ran into some very interesting challenges and learned a lot of stuff, but more importantly, I got to recreate something special from my childhood. And that makes me very happy. At the end of the day, I know it's just an algorithm following the rules defined by me, but making it finally work and watching a system of pipes emerge fascinates me for some reason. Maybe it has to do with my obsession with the original 3D pipes as a kid. Either way, I would love to explore more on topics like procedural generation, cellular automata, and emergent behaviors in the future. So if you're interested in any of those topics as well, make sure to hit the subscribe button and like the video. If you want to play with the project yourself or want to take a look at the source code, the links are in the description. Thank you for watching this video and I will see you in the next one.